So we just talked about special kinds of relations like orders, which are reflexive and transitive. And if you draw a graph of that relation, it's going to have a lot of edges. First of all, it's reflexive, so it has to have all the loops. So every time we draw a vertex, we have to draw a loop. And second, it's transitive. Every time we draw an edge from A to B and edge from B to C, we have to also put an edge from A to C. But we know it's there. Is there any way to draw it simpler? After all, if I give you this diagram of course prerequisites, you have no trouble figure out that you need to take 1001 before you take 2005, even though I didn't explicitly put an edge from 1001 to 2005. So can we do something like that in general, which would make nicer pictures for relations that are orders? By the way, prerequisite is not quite an order because you really can't take a course before you take the course. But still, this diagram gives us an idea of how we could simplify graphs if we know that the underlying graph is order. And the way of doing it is called the Hasse diagram. So that's exactly what we are looking for. It's a way of drawing an order when we don't draw the loops because we know they're there. We don't need to say it. And also, we don't draw any edges that are there because of transitivity. If we can get from 1 to 2 and from 2 to 3, well, we know it's an order, so we know there must be an edge from 1 to 3. We don't need to draw it. We could figure it out. Moreover, it has a diagram. We get rid of arrows because this time we draw the smallest, the minimal thing on the bottom and the maximal thing on the top. And every time we draw an edge, we draw it upward. So if there is an edge from something from one element to another, then we read it as the element below is related to the element above. So now that really simplifies our life because, for example, instead of drawing this 1 less than or equal to 2, 2 less than or equal to 3, with however many we have, 6 edges, all with arrows, 3 loops and 3 edges, we could just draw it as a diagram with only 2 edges without any arrows. So that's the Hasse diagram. They're especially useful if you're doing partial orders as opposed to linear orders, because then you can arrange things in layers and kind of relate everything to things right above it and right below it, and everything else you could just infer by transitivity. Also, with skipping all the self loops, we don't need them. So Hasse diagrams are a good way of representing a relation as a pretty much the simplest possible minimal amount of stuff that you need to draw to convey what your partial order relation is supposed to be. Okay, so let me finish with the following puzzle. As you know, some country recently got rid of a penny coin. And now, every time you pay by cash in a store, if something costs $2.23, you pay $2.25. It has to be rounded to the nearest multiple of 5 cents. Well, that's because the nearest coin that we have now is 5 cents. But here's the question. In the UK, they have another coin. They have a 3p coin. Imagine that instead of getting rid of the penny, we would replace a penny with a 3-cent coin. Would it make it possible to get rid of that rounding up from 223 to 225? Or would we be able to pay the exact amount? And if so, when would we be able to do it? probably cannot do it every time, because if we only have a 3-cent coin, we cannot pay 1 cent, we cannot pay 2 cents, and we cannot even pay 4 cents. But what is the largest number that we cannot pay with our 5s and 10s and quarters and the 3-cent coin? So think about it for next time, and also think about how you would convince somebody that there is indeed a larger number that you cannot pay by using 5, 10, 25, and 3.